I promised that I'd give you a tour of the schematic of the B&K. I was planning to actually do this earlier in the videos, but I decided to do it later for a couple of reasons. One is it'll let me give you a match between what you see on the schematic and what you actually see over here and in the circuitry underneath. And also, it'll give me a chance to review kind of the changes that I made in recapping and so on in the thing, as well as some basic ideas about how to work on these tube testers. Now, one of the things that you'll want to do is get yourself as much literature as you can on the particular tube tester that you're trying to rebuild. And understand, I'm not an expert on these. There are a lot better people on tube testers on the web and on YouTube, and there's also a lot of folks who have done a lot more restoration than I have of other stuff, radios and TVs. But these are just my experiences and what's worked for me. This is a manual that I got off of the BAMA website. BAMA stands for Boat Anchor Manual Archive, and if you just type BAMA manuals into a search engine, you'll find this site. This is the operation manual, and they also have the service manual at the same site. This is a voltage chart that I think you've seen, calibration procedures, service instructions, and so on. And I think this one on BAMA is called B&K 650 Cal. At any rate, it's in the B&K section of the BAMA website. And there's the service manual. Stapled them both together just for convenience here. So let's take a look at, oh, by the way, before we get too far down the road, another thing that I found very useful is this book on tube testers and classic electronic gear by Alan Douglas. If you really want to get into the hobby of collecting test gear, especially tube testers, you'll want to get a copy of that book. It's got a lot more information than I can give you in a week. Okay, let's start then with the transformer, because that's the place where most of the power for the unit comes. At the bottom here, you'll see a heater section. Over on the left, right here, you see the primary of the transformer, and that is connected through a fuse right there to the AC line. So if the fuse is good and you turn the power switch on, which is right there, the first thing you should see, there's the power switch, is this pilot bulb. This red bulb there coming on. Let me turn the power on here, and then the power to the tube tester, and you see it lights. Now, you may notice it's kind of dim, and there's a reason for that. In this, the pilot light is a number 44 bulb. You see it right here. By the way, the thing that I'm pointing with is a Weller desoldering tool. They're pretty handy for working on this old tube equipment. They come with a lot of the Weller soldering guns. It's a number 44 bulb. It's connected to the 2-volt winding of the transformer. 44 bulb is a 6.3 volt bulb, so what in the world is it connected to a 2-volt winding? Well, it turns out that once upon a time, they were using a 6.3 volt bulb on a 6.3 winding. And I'm going to go over here to the tube tester book and look under Hickok. I'm sorry, under B&K. And get the schematic of the 500. Here you'll notice that right there is a number 44 bulb, and it's connected to the 6-volt winding. So why did they connect it to the 2-volt winding in the 650? That, by the way, the 500 is the predecessor of this 650. Well, the reason doesn't have anything to do with that bulb. It has to do with this bulb right there. Notice I've written the word fuse alongside of it. And it is also a number 44. Right there. But it's used as a fuse. Well, originally, that was a number 49 bulb, which is a 2-volt bulb. But they had so much trouble with those burning out that users complained. So they wound up replacing this one with a number 44 bulb. In other words, they put a 6-volt bulb in a circuit originally designed for a 2-volt bulb. Then, in order to give you a replacement that was handy, they also changed the pilot light to a 6-volt bulb so you'd have a spare. And that's the reason why that in the 650 the pilot light is connected to the 2-volt winding. If you've ever done engineering, and I spent a good deal of time doing that, you know that this is one of those field expediencies that you put in so the production line doesn't have to shut down, and you don't have to retool everything. And anyway, that's the reason they did it. Okay, so the heater voltage is selected by this heater switch. This is the contact, and it moves up and down, going from 1 volt at the bottom to 50 volts at the top. You may also notice there's a 50 volt connection there that goes over to this neon bulb. Well, that is a feature that allows you to test the continuity of the heater in a tube before you go ahead with the rest of the tests. And for that to work, you need to move the heater switch down to the heater continuity position. I'll show you that in just a second. So over here we have a 6U8 plugged in. We're going to turn this on, and then we're going to turn the heater continuity down to there. And you'll notice right over here that this neon bulb, this one right here, comes on to show you there's heater continuity. The next thing you do is you set the heater voltage, in this case to 6 volts. On the schematic, that is this pair of lines that comes out over here to the heater. By the way, if you set the heater switch to the 50 volt position and with the unit unplugged, you test across the heater connections, you should get about 18 to 20 ohms. If that's there, you know that the entire heater winding is good. Now, there might still be some problems with an individual selection, but at least the winding is continuous from bottom to top. While we're talking about that and the fact that you need to do that with the power off, I should point out that if you don't really know what you're doing when you're working on one of these, you should get some more experience. Don't ever work on something if you don't know what you're doing. These can be dangerous. A couple of ways to find out what to do is to go on the internet, YouTube and other internet resources. But another resource that you might want to consider is whether there might be a local radio club or ham radio club or whatever in your community. You might try going to their meetings and meeting up with some of the old folks that used to work on this for a living like I did. They're usually very happy to help you, and they can give you some tips and some ideas that'll keep you a little safer. And it really is important that you not try to work on this unless you know what you're doing.